Please allow me to read their bios in order of which they will speak. First, Loretta Mokry has over. I thought you told me the other way around. Okay. In the order in which they will speak. As the Assistant Deputy Water Resources, Galen Roberts oversees all aspects of water resource management, watershed protection, and lake and wetland operations for the North Texas Municipal Water District. Galen and his team are responsible for managing the district's East Fork raw water supply, Bois d'Arc Lake, and more than 17,000 acres of environmental mitigation areas. He also manages the district's water rights portfolio and works closely with water treatment and conveyance staff to make efficient use of the district's water supplies. Galen holds a Bachelor of Science degree from Texas Tech University and a master's in water management from Texas A&M University. Next, Loretta Mokry has over 43 years of experience in environmental and economic studies, including constructed wetlands, wetland delineations, Section 404 permitting, mitigation plan development, implementation, and compliance monitoring, threatened and endangered species surveys, NEPA compliant environmental assessments, water quality studies, stormwater permits, non-point source evaluations, and environmental site assessments for various clients. Please welcome our speakers.
Good afternoon. Appreciate being here. I'll say it's my first time being here with this group, but I really appreciated the sound of all the discussion, all the talking happening before the meeting. I think these kind of networking opportunities in these groups are absolutely excellent. So I'm excited to be here today. Appreciate the opportunity to talk about our project and look forward to answering any questions you may have. We'll be around afterwards as well. So with that, as mentioned, I'm Galen Roberts. I'm with the North Texas Municipal Water District. We're here today to talk about one of our premier projects. It's the East Fork Water Reuse Project. But first, I'd like to orient you a bit to who we are at the district. We are a regional water, wastewater, and solid waste provider, serving approximately 2 million people and growing on the water system side. So we serve mostly north and east of Dallas. I like this map because it provides a good landscape of who serves what. But Dallas there in purple being central. Our service area is shown there in green. Again, primarily north and east of Dallas. And then also shown on this map are two other major water providers in the Metroplex. That being Tarrant Regional Water District there in blue, and then the Upper Trinity Regional Water District shown there in the hatched area. We're probably most like the Upper Trinity Regional in that we are a treated water wholesale provider. So we treat water at one of 6 treatment plants and then deliver that to the member and customer cities that we serve, who then distribute that to individual homes and businesses within their service area. As far as water supplies, we have reservoirs including Lavon Lake, Lake Texoma, Tawakoni, and Chapman Lake, from which we draw raw water supplies. Those are Corps operated and owned reservoirs. Our newest reservoir, which is owned and operated by the district, came online, began treating water this spring, and that is Bodark Lake in Fannin County to the north. It's a really exciting project. It'll be a separate discussion, but that's the first major reservoir built in Texas in 30 years. So it's very exciting project for us. Again, just came online treating water at our newly constructed Leonard Water Treatment Plant in the spring. But these are our water supplies in terms of reservoirs. We also have significant reuse supplies, which is what we're going to be talking about today. And as mentioned, that is reuse of treated wastewater effluent that is discharged into the East Fork of the Trinity River and the main stem of the Trinity River. We divert and then treat that through 2 pump stations and then at a constructed wetlands, which we refer to as the East Fork Water Reuse Project. I mentioned growing earlier, and we are doing just that. The entire Metroplex is growing significantly, has been, and does not show any signs of slowing down. For our service area alone, our estimates are we're adding over 55,000 people a year, and will continue over the next several decades. So we've got big challenges ahead of us as an organization for meeting water supply demand now and into the future. And I'll talk about it, but this East Fork project, which came online in 2009, was absolutely critical for us in terms of our ability to meet water demands at that time and into the future, especially with the recent growth we've seen over the past few years. But, you know, I'll note here a few key points. We're currently serving over 2 million people, and we expect that number to nearly double over the next 50 years. Many of the cities that we serve, again, north and east of Dallas, are some of the fastest growing areas in the country. So, I mean, we routinely see reports from Census Bureau and other sources naming cities within our service area, and the true is it's true across the Metroplex. So it's not unique to just us and our organization. But the water supply challenges are great for the Metroplex, and it will take a combination of solutions to meet those. In the water world, we generally plan for a 50-year horizon. We undergo a regional and a state water planning process that looks over that 50-year term. These numbers I've shown here are from the Region C plan. That's the region which Dallas-Fort Worth lies. These are Water Development Board, Texas Water Development Board planning regions. But as you can see from the most recent Region C plan, it is going to take a combination of water supplies to meet future projected growth and demands. So, of course, new reservoirs like Bodark Lake will need to be constructed, but a significant portion of that future demand is going to be met through conservation and reuse, almost a third between those two strategies alone. So it's a significant part of our portfolio and will remain a significant portion now and into the future as we look to additional reuse supplies moving forward. But to talk about the wetlands specifically, this is a constructed man-made system. It's approximately 2,000 acres in size and located near Seagoville, Texas, which is just southeast of Dallas proper. You can see some aerials shown here in Loretta, and in the latter portion of this presentation, we'll talk about the specifics of the wetlands and how it functions and how we operate and maintain it. But it is really a neat facility. It's owned and operated by the district, my organization, but there is a nonprofit center that's located within the heart of the wetlands. That is the John Bunker Sands Wetland Center. It's named for the individual who oversaw and owned that property prior to the district acquiring it, and which is a really neat origin story for how the project came about. But real quick on that, John Bunker Sands is one of the individuals that's part of the family behind the Rosewood Corporation. And it was part of Rosewood's cattle operation, this property, prior to our developing it as a wetland. He himself had identified the potential for that site for wetlands development. And it was a fortuitous situation. We shared a common consultant that brought us together and ultimately led to our developing the project in partnership with the Rosewood Corporation before acquiring it after it was built. But this nonprofit center is really an extraordinary place. It's open to the public. Their focus is on education, both for adults, but largely for school groups. So we have schools that come out regularly to visit the center and learn about wetlands, science, water supply, a range of topics. But it's also very popular with the birding community. There's over a mile worth of boardwalk. You can get out on the wetlands. So perhaps not in August, but this fall, if you want to spend a Saturday, take the kids out, it's really a neat place. There we go. So to kind of orient you to how this wetlands operates in terms of a water supply and what it means for us, you can see Lavon Lake at the top of this graphic. Below it, along the East Fork of the Trinity River, is Lake Ray Hubbard. If you follow that East Fork south, that's where our constructed wetlands is located. So it's adjacent to the East Fork of the Trinity River, south of Ray Hubbard, but upstream before the East Fork has a confluence with the main stem of the Trinity. We divert water directly out of the East Fork of the Trinity River into those wetlands. And again, those volumes are based on treated wastewater effluent volumes, which are discharged into that watershed upstream. So those are facilities that we operate or have agreements in place with, but it's largely our service area. So it's water that we deliver that we're reusing after it's been used and treated at those facilities. We also have an arrangement with the city of Dallas. So for those facilities that discharge into Ray Hubbard, the city of Dallas releases those equivalent volumes downstream so that we may divert it from the East Fork into the wetlands. We also recently completed construction on a new pump station on the main stem of the Trinity River. So in addition to diverting volumes from the East Fork, we also divert volumes from the main stem of the Trinity, pipe that upstream into the wetlands, and then all the water that flows through that wetland system, both from the East Fork and the main stem of Trinity, after it works its way through that system, is pumped up back to Lavon Lake. So we pump that water up into the upper reaches of the eastern arm. It allows time for that water to blend. Also additional detention time for treatment before we ultimately bring it into our water treatment facility located at Wiley. So a bit about the main stem pump station. The wetlands have been online and operating since 2009, but this is our newest addition to that system. It was fully operational 3 years ago in 2020. The distance between that facility and our East Fork wetlands is approximately 17 miles. It's over 40 miles that we pump it from the wetlands up to Lavon Lake. So we've got significant miles of large diameter pipelines to convey that raw water, again, up to the wetlands, but also ultimately up to Lavon Lake. As far as capacity here, this pump station can deliver just over 100 million gallons per day, but in terms of a reliable supply, it represents 50 million gallons per day. So if you combine that with what we can reliably divert out of the East Fork of the Trinity River, we can get a reliable supply out of this system of 90 million gallons per day. Now, that's what was the basis for the design for the wetlands itself. A bit about water rights. So we have rights to those volumes in the East Fork, which we divert directly into the wetlands from the East Fork of the Trinity River. We obtain water rights do that. It was actually based off of our water rights for Lavon because that's where the volumes are ultimately discharged to. But there are some unique conditions within that permit that are intended to help ensure there are adequate flows within the East Fork of the Trinity River for the benefit of downstream water right holders, but also for biological and ecological purposes. So we bypass certain flows within the Trinity River Basin and also have requirements for maintaining flows within the East Fork and the main stem in terms of our pumping operations. So I like to show this slide. This is my last slide, but it really, in my mind, gives a good comparison and perspective for what this represents to us in terms of a water supply. So the reliable supply I mentioned out of the East Fork project is approximately 90 million gallons per day. Compare that to the firm yield of Bodark Lake, which is our newest addition, our newest reservoir. That's the equivalent of another lake. And at a fraction of the cost, a fraction of the size, and a fraction of time to permit and construct. So reuse for us has been absolutely critical, but it's also been a very cost-effective solution to making additional use of our existing supplies and meeting those demands we're seeing within our service area. And at this point, I'll transition to Loretta, who's going to talk about operation and maintenance of the system itself.
First, I'm going to expand a little bit. First, I'm going to expand a little bit on the permitting that Galen started with. Can you help me out, Paige? Testing, testing, testing. Okay. All right. We're going to expand a little bit on talking about the permitting for the project. The initial project components, the diversion pump station on the East Fork, the East Fork wetland, the conveyance pipeline all the way back up to Lavon, and the outfall at Lavon Lake. the permit required was an individual 404 permit. Of course, you have to have the water quality certification permit from TCEQ that goes along with that. It took us 15 months from the time that we actually submitted the complete permit application to where we had the permit in hand and were able to start construction. So we were working on all the permitting as they were continuing doing the design. And we're coordinating very carefully with the Corps and all of the coordinating review agencies during that time. As soon as we got the permit, I had a couple of design modifications that the engineers had done and didn't bother to convey to me, that we had to do a modification of the permit because we'd been working so closely with both the Corps at the regulatory branch as well as with the operations people at Lavon. We were able to continue construction during that time while we were working on the modification of the permit. The impacts to wetlands that were there on the ranch. Bunker Sands had already done some restoration and created some duck habitat cells. That's really what threw us into the individual permit. So we had quite a bit of marsh type wetland there that was being impacted. That was determined to be self-mitigating because that's what we were creating again with our constructed wetland was the marsh area. But we also had impacts to waters of the U.S. with all of the stream crossings that we had going up to Lavon, as well as at the intake at the East Fork Trinity River. And then we had impacts on the federal property under the 408 permit that required mitigation. We were able to do all of our mitigation on the federal property up there at Lavon. Permit. That's required because you had crossing with the pipeline of the federal Corps flood control levees, as well as crossing with the pipeline on federal property up at Lavon Lake. So that was done concurrently with the 404 permitting, and we were able to do all that mitigation. The mitigation that we did up there at Lavon was the native prairie restoration of 109 acres, as well as some forested riparian area wetland restoration along one of the drainages going into Lavon, and then a little bit of emergent wetland that we had to do within one of the cove areas. That was actually, it's only a little over an acre, but it was some of the hardest mitigation to do because Lavon was about 15 feet below conservation pool at the time we started the project. We had to wait about 4 years before lake levels rose enough to where we could actually do some wetland plantings in that cove area. Okay, we'll try it again. For the main stem pump station and pipeline, we started out thinking that we would be able to get it permitted under a nationwide permit. And that's what we submitted 2 nationwide permit applications for. Unfortunately, we ended up having crossings of the federal levees again, and that required the 408. So it ended up being both the 408 and 404 authorized under Regional General Permit 12. One of the reasons we were thinking we needed a nationwide permit, and we'd hoped for this with the regional general permit, was we needed a fast track permit. As it ended up, the Corps required, because it's a water supply, we were taking water out of the river again, even though we already had water rights. We had to do quite a bit more data analysis and modeling to show that we weren't having an ecological impact to the river. It still took us 13 months to get this one permitted. We were able, with the Corps crossings of the Corps levee for the pipeline, to be able to use a programmatic environmental assessment that the Corps had developed in 2011. So it was not a major federal action, didn't require us to do an environmental impact statement. In fact, they fairly streamlined it. So that part went through pretty quickly. We did have minor impacts to a small forested wetland along the pipeline route. For that one, we were able to buy mitigation bank credits. Going back to the wetland, if you look at the site at the Seagoville Ranch where this was developed, this ranch had been producing crops and cattle for over 100 years. And that is something that, you know, as we're out there, we recognize we really don't have much in the way of a seed bank, and we needed this project out quickly. But one of the key things in looking at this site is when it was being used for producing all these agricultural crops, they'd actually developed agricultural levees around the north and central section, and then also had the core flood control levee around the south section. So there is some flood protection of the site. It's not a 100-year flood protection, at least not on the north section, but we do have for just a 10, 15, 25-year flood protection. We're not going to be flooding the wetland, which was critical. You can see the distance and constraints that we had with the site. We actually have 3 different sections. You have the north section, central section, and south section that was developed. In the major project components, we had the diversion pump station that's there on the East Fork Trinity River that Galen mentioned. You have the constructed wetland itself. The 1,840 acres is wetted surface area within the 2,000-acre easement that they had. The conveyance pump station that pumps the water back to Lavon Lake. The conveyance pipeline, 43.5 miles of 84-inch diameter. The John Bunker Sands Wetland Center that is located centrally within the site where they do the educational component. And then the main stem pump station and pipeline that came on in August of 2020. Looking at, I don't know how you do well, you can see where the diversion pump station is there on the East Fork Trinity River, and the water that comes from the main stem pump station comes just past that pump station, and both of them are commingled in the splitter box. The splitter box discharges to 3 sedimentation basins and then to 3 small wetland cells in the north section. That's gathered and has to be conveyed through culverts under the Highway 175. It flows through the central section in 3 wetland trains, has to be gathered again into a channel, and then culverts under the core levee, then distributed to 4 wetland trains in the south section. Then that flows down into the holding pond there at the conveyance pump station. Then that's where it's pumped back to Lavon. Okay. Oh, I missed one. This is just a quick picture of Google Earth from the main stem pump station. See, it's a little bit different. It has a 4-bay down there. But if you'll notice, there's the lock and dam structure that's just downstream from where the intake is. This was a key factor in locating the pump station here, because that lock and dam maintains a steady pool there in the Trinity River for the intake to be located within. Within the wetland, there's a number of different removal mechanisms that function synergistically to provide the water quality improvement, primarily focused on removing suspended solids and nutrients, nitrogen and phosphorus. But all of these actions are working together and sometimes separately, but sometimes things can happen within the wetland as well, which is what we'll talk about in a minute. But looking at wetland performance, I focused on phosphorus because phosphorus is really the key nutrient that controls algal blooms up in Lavon within a reservoir. We do have some seasonality with the phosphorus. If you look at mass removal, it looks like it stays pretty steady. We got 55% mass removal overall, and that just ranges from about 53% up to 58%. But if you look at concentration removal, you can see that we have more of an impact during the summer where we have much less concentration removed for the phosphorus. This is because we have a lot of biological activity, in particular with carp, that stir the bottoms and resuspend not only sediments, but release a lot of the phosphorus from those sediments. Looking at the overall water delivered from this project, so far since it's been in operation since 2009, it's 143 billion, that's billion with a B, gallons of water have been delivered back to Lavon. Looking at the TSS removed, you can see we're a little over 24,000 tons. And removal about 54%. For the total nitrogen removed, we've got almost 1,500, sorry, can't read without my glasses here, but almost 4,500 tons of nitrogen have been removed, about 75% mass removed with the total nitrogen. And again, with the total phosphorus, about 55% mass removed, or about 685 tons have been removed. People ask me, well, this is a natural system, so it really kind of operates itself, doesn't it? Well, yes and no. There are ongoing operation management that's required within a constructed wetland. You don't have the concrete and steel and air blowers and other mechanical things that you have at a conventional plant, but we do need to be able to manage water levels within the cells to make sure that we're not having adverse impacts to the aquatic vegetation. You need to manage the flow, balancing or proportioning between the trains so that you're effectively using the treatment area, and you need to be monitoring water quality. And then you have vegetative cover. Again, the plants are a very key component of this wetland. They provide the structure within the water column. They provide not only structure, but organic carbon for the microbial population to colonize and to grow on. And then when we have issues or impacts to those plants, then we do remedial planting. And that's something that is ongoing to different areas. For instance, where we have wildlife that does impacts. We have woody vegetation control. Willows and cottonwoods and things like that are really not desirable within the marsh areas because their roots can penetrate through the clay bottom. And then they also produce a lot more, lose a lot more water through their evapotranspiration. In the wintertime, we do prescribed burns that removes a lot of the accumulated thatch from the tall plants. And then it generates a lot of robust regrowth of those plants in the spring, which really helps pick up more nutrients. You have a lot of invasive species management. In particular, we have a lot of nutria that came in first. The nutria are very destructive to the plants as well as to water quality. We have a lot of feral hogs. The nutria are controlled through hunting. The feral hogs now, we have an active trapping program that's on the way to try to keep them in control. Looking at carp control, as I was mentioning, the carp stir up the bottoms a lot. That can be very detrimental to removal of our suspended solids and also to the removal of our phosphorus. So one of the ways that we treat that is we have drain down a cell and then have large pumps where they actually pump out the deep water zones. And we have a number of predators then that eat the exposed fish. You can see the picture on the left. We had TSS before treatment. TSS was at 135 milligrams per liter. After treatment, TSS is 13 milligrams per liter. The carp have a significant impact to your suspended solids. And then again, with the vegetation, with the different animals that we have in there, or sometimes with the different flows, we'll have short circuits that develop. If you have your flow going through a short circuit, you may have 80–90% of your treatment marsh that's really not functioning very well. So some of that we can treat. If it's a fairly minor one, we'll treat with some remedial planting. Larger scale ones will require some regrading and activity going in to block that short circuit. Levee embankment and road repair. When you've got animals out there, the nutria like to burrow into the levees, and the picture in the upper left is where they had basically built their tunnels and mined within one of the levees up there in the central section. And then the big hole that you see on the upper right is where you actually had a culvert pipe separated and the dirt fell in. So, repairs are ongoing. The hogs can tear up the levees and the roadways. So in addition to trapping, then they have to go back in and do some repairs. And then there's also routine mowing. I keep trying to convince the operators if they'll just mow the top and upper slope of the levee and leave my profit sedge along at the base, it keeps the toe of the levee a lot more stable. But that's what we're targeting is trying to keep things looking neat, but also stable. Now, if there's any questions, Galen and I will be happy to try to follow up with you.
Thank you, Loretta and Galen. Are there any questions? We have a few minutes if there are any. Okay.
We are hiring.
So it's only staff?
Yeah, it's only staff, and in fact, our crew there at the wetlands are the only staff in our organization. They're allowed to carry and use firearms, and it's for a very specific purpose and need, which Loretta outlined very well. But yeah, we're very safety minded there, especially with the relationship with the center and kids being on site, at least for a portion of the wetlands. So I've asked the same question, but the answer is no for me too.
Any other questions?
It seems of phosphorus and nitrogen you're keeping out of Lake Lavon. So any indications whether that's helping to maintain the lake water quality and longevity of the lake itself?
So absolutely, it's having a benefit. We've done some modeling within Lavon Lake, looking at, at what point might we see water quality issues develop, because there's loading from a number of sources, and you got non-point sources, other wastewater effluent discharge, and so it's increasing over time. But we don't believe, based on the models we've run, that we're going to have major issues like algal blooms, at least within the foreseeable future. And I attribute that in part, at least, to the significant removal rates that we've seen from volumes pumped. And I'll note it's the wetlands themselves, the function, but it was also a very deliberate choice for us in terms of design to locate the outfall at the upper reaches of the pond. So you've got that opportunity for that blending, that detention time, and to minimize impacts in the lower reaches of the lake where we're diverting water for treatment purposes.
In addition to protecting the lake and the water quality that we need provide to the service area, the nutrients that we capture within the wetland drive a tremendous primary productivity within that wetland that supports the wildlife that's there. So what we see, like just in one example, when they do the Christmas bird counts, and there's big quadrat, and it's divided, the Audubon Wetland Center, which if you're familiar with on the south side of Dallas, has a very high diversity of birds. We see that same diversity or a little bit more at the East Fork wetland, but we'll see 10 times the number of birds at the wetland coming through in the migration. And that's just the migratory birds really that are coming through. We see that with river otters and mink and bobcats and everything else that's out there. So that capture of nutrients is important within the wetland as not only protecting water supply, but also to drive that primary productivity there at the wetland and support that habitat.
I'd like to really thank y'all for speaking today. We've got a few speaker gifts for you. ASCE portfolio, padfolios, whatever. And thank y'all so much. Hope you come back and visit sometime. A lot of our topics are transportation, so we try to liven things up with a diversity.
Can I say one thing?
Yeah.
I did, in closing, want to acknowledge Tim Noack with Plummer here. He spoke during the technical session, but like Loretta, with Plummer and Associates, and played a very key role in bringing this project. So Tim, thank you.